Welcome everybody, this is iZotope R8 Advanced Tips and Tricks here on Groove 3. As I'm sure you know, iZotope RX8 is a powerhouse in audio restoration and repair. This toolkit really has everything you could possibly need in that realm. So we're going to be talking a lot about restoration and repair, taking good audio and making it sound great, or taking bad audio and making it sound as good as possible. In addition to audio restoration and repair, there's also lots of opportunities to creatively manipulate your audio in iZotope RX8. So in addition to focusing on restoration and repair, I'd like to also go over some tips and tricks on how to be more creative while using RX8 as well. Before we jump right in, I do want to point out that we will be using iZotope RX8 Advanced for this series. So if you have the standard version or just the elements, you will see tools that you don't have access to. It doesn't render the whole thing useless to you. There's still a lot of things we'll talk about that you do have access to, but just note that we are using the advanced version of the software. On that same note, I'd also like to point out that I will be using iZotope RX8 as a standalone application because every DAW accesses RX a little differently. For instance, in Pro Tools, you're going to be using RX8 as an audio suite plugin, whereas in Logic Pro X and lots of other DAWs, you're going to be setting RX8 as your external sample editor. So there's really just too many variables to go over all of them in this series, but note that as you access RX8 from these other applications, you would be sending the audio to RX8 and using it in the standalone application regardless. So the workflow will be exactly the same as it is once you've gotten the audio into RX8. So with all that out of the way, let's jump in and start familiarizing ourselves with what exactly we're looking at when we look at RX8. Because one thing's for sure, when you first open it up, you're viewing audio like you've never viewed it before. No other DAW looks anything remotely like this. By default, you can see both the regular waveform and the spectrogram, or the spectral view. This can be a little hard to work like this though, so luckily there is a slider where you can go all the way to the left to see the regular waveform, or you can go all the way to the right to see only the spectral view, and of course anywhere in between. So when you're normally looking at a waveform, you're looking at two dimensions of audio. You have the x-axis, which shows you the time. So as you're on the left-hand side, you're at the beginning of the track, and your right-hand side is the end of the track. So fairly easy to comprehend, the x-axis is time. The y-axis shows you the amplitude. So the louder a sound is, the more of the y-axis it's going to take up. So these areas where there's not much on the y-axis, those are very quiet. And something like this, where there is a peak, we know that those are louder areas of the sound. So that's kind of how we're used to viewing a traditional waveform. However, RX has introduced the spectral view, which is actually 3 dimensions of information. There's a lot of visual information here. Your x-axis is still, of course, time. However, your y-axis now is frequency. So the further down on the y-axis the sound appears, the lower the frequency, and the higher it appears, the higher the frequency. Now, because we've used up our y-axis for frequency instead of amplitude, the good folks at iZotope have been forced to display the amplitude in a completely new and different way. So you'll notice that we have kind of a gradient between this bright orange all the way down to black, with kind of a dark blue being in the middle. So the black represents areas that there is absolutely no information whatsoever. Then the dark blue represents an area where there is information, but it's very small amounts of information. So it's a very quiet sound. A lot of the time it is just noise from the room or from an air conditioner or any number of things. And then of course our orange represents louder sounds. So the brighter the orange is, the more information is being represented there. So that's 3 dimensions of visual information all hitting your eyeballs at once, and it's a lot to take in. Fortunately, they've made it so you can change the frequency scale of the spectrogram. And what I mean by that is What I've noticed is a lot of the information that I actually care about is in this 1K and above range. Very little of the time am I actually worried about anything below 1K. It does happen, but 95% of the time I'm focusing on noise and things like that that are above 1K. So they've made it so my scale doesn't really have that much focus below 1K. You can see the numbers are fairly bunched up down here. But this is just one of the frequency scales we can view. If you right-click here on the frequency panel to the right of the spectrogram, you'll notice that you can change the frequency scale to 5 different settings. The linear scale means that the hertz are linearly spaced up and down the screen. So this is technically the most even way to view the spectrogram. However, I also find it in some ways the most useless way to view it, though, because apart from getting a very accurate idea of what frequencies are sounding at any given point in time, it's very difficult to actually work in this linear scale, which I'm sure is why the geniuses at iZotope have programmed in the other scales as well. The Mel and the Bark scales are both very useful and they're both very similar. These are scales commonly found in psychoacoustics, so I feel they more accurately reflect how our ear actually detects pitch. So instead of being just a scientific scale that works great on paper, but is hard to relate to as a human being, they actually seem to look a lot more like how I interpret pitch. They're both approximately linear below 500 hertz and approximately logarithmic above that. And as we switch back and forth, it's pretty easy to see the main difference between the two is the Bark scales a little more focused on the low end, the Mel a little more focused on the high end, but really they're quite similar. Next, let's look at the logarithmic scales. So in log mode, all the different octaves occupy equal screen space, all the way down to 100 hertz. So this shows you a lot more of the low end and a lot less of the high end. Then the extended log is exactly the same, but it goes all the way down to 10 hertz. So you can see even more of that really, really low end. We're down to the rumbling. Maybe it's a windy recording, things like that. It's nice to be able to see it, although there is a de-wind module that we'll talk about later that pretty much cleans all that up effortlessly, but it's still nice to be able to see what the problem is, and these logarithmic scales will help you do that. I'm going to go ahead and switch it back over to Mel now. And something else that's pretty cool, you can also have it show the piano roll. So if you're very musically minded and you want to see what notes on the keyboard correspond with each of these frequencies, you can do that by showing the piano roll. So that's everything for this video, except I want to give you some words of encouragement because I know this is a tremendous amount of visual information. It's unparalleled. We're being honest, when you're first starting off, it feels very daunting and a little bit scary. But I want to tell you before we move on that really it doesn't take too much time at all, and you start to speak RX. And what I mean by that is when you look at an audio file, you can tell a lot about it. Just by looking at this, I can see this isn't rhythmic, but there's tonal audio, there's sibilance, so I know that this is most likely a dialogue clip. And a fairly noisy dialogue clip at that. I see there's some interference up here, kind of towards the 10.5K range, as well as most likely down here in the 900 hertz. And I see what are most likely some mouth clicks in here and right here as well. And there's also just a fair amount of noise that might be wanted, but probably not. The only way is to listen to it. So let's listen to this and see what we've got.
Really hard news.
It was stage 4 rhabdomyosarcoma, which is a very rapid moving childhood cancer.
So we're going to be working with this clip later in the series. I want to show you how to get it cleaned up and sounding as good as possible. But for right now, I just wanted to show you how much information we can get just by looking at this clip on the spectrogram. And it's almost like learning to speak a new language, which is why I call it learning to speak RX. And once you've got the hang of it, you can see lots of different things on all kinds of clips. I've got a song here pulled up, And I can tell it's a song because it's very rhythmic. I see a kick snare pattern at the beginning. I see the bass coming in with more sustain, rocking an eighth note feel. You can still see the kicks in there, but those bass notes are definitely hitting in eighth notes between the kick drum. I see lots of sweeping patterns going through the upper frequencies. You can usually tell where and when a vocal comes into a song because they have a fairly distinct pattern as well. Generally, a vocal is in this rough frequency range, and the big thing is that they're not perfect. Whereas over here, before the vocals come in, you see notes in that same frequency range, but they're all held out perfectly. They cut off very accurately, and humans just typically don't do that. We run notes into each other. We don't hold things perfectly. We use vibrato. And so it's fairly easy to spot a human vocal rather than an instrument, especially an instrument like a keyboard or a synthesizer. So just looking, there's tons of clues here. And the more you use RX, the more you know how to spot these things. I just wanted to take a couple minutes and show you what you're looking for when you're looking through the spectrogram, because if you know what sorts of things you're looking for, it's much easier to spot them. So that's everything for this video. In the next one, we're going to be going over the rest of the interface, talking about all the meters, zoom controls, selection controls, the transport, and everything you'll need to know in order to operate the actual application of iZotope RX.